Good evening, my dear students. Now, one more point remaining in the electric potential and capacitor chapter, but that is asked in the examination repeatedly for 3 marks. Tomorrow I will give that question and you have to write in the practice test. Therefore, I want to explain here in this video clip. This is very important. That is the relation between what you say the electric field and electric potential due to a point charge. But in previous video clips on that second chapter in the electrostatics, you have to derive that relation between the electric field and electric potential by using equipotential surface. ಆದರೆ ಇಲ್ಲೇ ನಾನು ಏನು ತಗೊಳ್ತಾ ಇದ್ದೀನಿ, ಡ್ಯೂ ಟು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇದೆ, ಅದು ಭಾಳ ಸರ್ತಿ ಎಕ್ಸಾಮ್ ಕೇಳಿದ್ದಾರೆ. ಏನಾಗಿರೋದು? It is the point charge, it is placed at point O. Then now electric field away from the charge, and A and B are the 2 points. A and B are the potential at point A and point B, and these 2 points are apart at a distance dx. Now potential at point A is Pa and potential at point B is Pb. Fine. Now A is greater than Pb. Then potential difference is difference of these two, Pa minus Pb. Now the charge move from B to A against electric field. Small work done, that is dW is equal to what you say vector F dot vector dx, but dW is equal to F dx cos theta. Theta is 180 degree opposite to this one. Cos theta is equal to -1. dW is equal to minus F into dx. You say equation number 1. Now by the definition of potential difference, dV is equal to amount of work done divided by the charge. This is equal to minus F into dx divided by Q. Now dV is equal to what you say minus F upon Q into dx. Here F upon Q is nothing but electric field E. Therefore finally what you say, dV is equal to minus E into dx. Therefore E is equal to minus dV by dx. This is the relation between what you say electric field and the potential difference. ಇದು ಎಕ್ಸಾಮ್ಗೆ ಪದೇ ಪದೇ ಕೇಳಿದ್ದಾರೆ. ಏನು ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂಡ್ ದಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಡ್ಯೂ ಟು ದ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್. ಇನ್ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್ನೇ ನಾವೇನು ಮಾಡಿದ್ದೀವಿ, ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಸರ್ಫೇಸ್ ತಗೊಂಡು 2 ಸರ್ಫೇಸ್ ತಗೊಂಡು ನಾವೇನು ಮಾಡಿದ್ದೇವೆ ಇಲ್ಲೇ ಪ್ರೂವ್ ಮಾಡಿದ್ದೇವೆ ಇದನ್ನು. ಬಟ್ ಇಲ್ಲಿ ತೊಗೊಂಡ್ವಿ ಪಾಯಿಂಟ್ ಚಾರ್ಜನ್ನು. ನಾಳೆ ಪ್ರಾಕ್ಟೀಸ್ ಕೊಡೋ ಕ್ವಶನ್ ಒಳಗೆ ಇದನ್ನು ಆನ್ಸರ್ ಬರೀರಿ, ಅದನ್ನು ಬರಿಬೇಡಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೆಲ್ಲ ತಿಳಿಸ್ರಿ, ಯಾರ್ಯಾರು ಈ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡ್ತೀರಿ, ಇದು ನ್ಯೂ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ಇದೆ, ಎಲ್ಲರೂ ನೋಡ್ರಿ ಅಂತ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಏನು ಮಾಡಿರಿ, ಮೆಸೇಜ್ ಕೊಡ್ರಿ. ಆಮೇಲೆ ಪ್ರಾಕ್ಟೀಸ್ ಟೆಸ್ಟು ತಪ್ಪಿಸ್ಬೇಡ್ರಿ, ಸಿನ್ಸಿಯರಾಗಿ ಬರಿತಾ ಹೋಗ್ರಿ, ನಿಮ್ಗೆ ಭಾಳ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ನಾ ಎಕ್ಸಾಮಿಗೆ ಬಂದಿರತಕ್ಕಂಥ ಕ್ವಶನ್ಸ್ ಮಾತ್ರ ನಾ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ನಿಮಗೆ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಯಾವುದಕ್ಕೆ ಪ್ರಾಕ್ಟೀಸ್ ಟೆಸ್ಟ್ಗೆ ಪದೇ ಪದೇ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋದ್ರಿಂದ ಭಾಳ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸಾಕಷ್ಟು ಮನೆಯೊಳಗೆ ಟೈಮ್ ಇರ್ತದೆ, ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡಬೇಡ್ರಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. In this video clip, I'm going to explain or discuss about the parallel combination of the capacitors. In previous video clip, there is a series combination of that is capacitors. Here you take parallel combination of the capacitors, particularly for this is 2 capacitors. In your syllabus only that is parallel combination of 2 capacitors is there. Yes, fine. What is the meaning of parallel combination of capacitors? Now, 2 or more capacitors, they are connected across 2 common terminals. Across 2 common terminals A and B. This is called parallel combination of capacitors. Once again repeat, 2 or more capacitors are connected across 2 common terminals by applying the potential difference. This is called what you say parallel combination of capacitors. Now C1 and C2 are the capacitances of the 2 capacitors. They are connected in parallel across the 2 terminals A and B. Cp is equivalent capacitance of the parallel combination of the 2 capacitors. Then plus Q1 minus Q1 charge in the first capacitor C1, and Q2 and minus Q2 are the charges on either plates of the second capacitor, and plus Q and minus Q is used to be total charge of the parallel combination of the capacitors. In parallel combination is very 2 important points. One is potential difference across each capacitor is same. ಇದಕ್ಕೆ potential drop ಎಷ್ಟಿರುತ್ತೋ ಇಲ್ಲಿನೂ potential ಅಷ್ಟೇ ಇರುತ್ತೆ. ಇಲ್ಲಿ 2 ವೋಲ್ಟ್ ಇದ್ರೆ ಇದು 2 ವೋಲ್ಟ್ ಇರುತ್ತೆ. ಆಮೇಲೆ ಚಾರ್ಜ್ ಆನ್ ಪ್ಲೇಟ್ಸ್ ಆಫ್ ದಿ ಕೆಪಾಸಿಟರ್ ಇಸ್ ಡಿಫರೆಂಟ್. ಇದ್ರ ಮೇಲೆ ಇರುತ್ತೆ ಚಾರ್ಜ್, ಇದ್ರ ಮೇಲೆ ಅದೇ ಇರುತ್ತೆ, ಬಟ್ ಇದರಲ್ಲಿ ಎಷ್ಟಿರುತ್ತ ಇದರಲ್ಲಿ ಅಷ್ಟೇ ಚಾರ್ಜ್ ಇರಲ್ಲ, ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ಯಾವಾಗ ಬೇರೆ ಬೇರೆ ಕೆಪಾಸಿಟರ್ ತಗೊಂಡಾಗ ಸಪೋಸ್ ಸೇಮ್ ಕೆಪಾಸಿಟನ್ಸ್ ಇರ್ತಕ್ಕಂಥ ತಗೊಂಡ್ರೆ ಇಟ್ ಇಸ್ ಸೇಮ್. ಓಕೆ, ನೌ Q1 is the charge in the first capacitor, Q2 is the charge in either side plate of the first capacitor. Then total charge is Q1. Here total charge is Q1 plus Q2. Q1 plus Q2 on either side plate ಮಾತ್ರ ತಗೋಬೇಕು ಟೋಟಲ್ ಚಾರ್ಜ್. ಮತ್ತೆ ಇದು ಅಷ್ಟು ಕೂಡಿಸೋಂಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ 0 ಬಂದ್ಬಿಡುತ್ತೆ. One side in plate ಮಾತ್ರ Q1 plus Q2. By definition of capacitance, C is equal to Q by V. Already you know this one. Then Q is equal to what? CV. Then charge in the first capacitor Q1 is equal to C1 into Vp, and charge in the second capacitor Q2 is equal to C2 into Vp. Vp is common here. Why? Because potential drop across each capacitor is same. Now total charge is equal to Cp into Vp. Equation number say 4. Now equation 1 becomes your substitute. Q Cp into Vp, Q1 C1 into Vp, Q2 C2 into Vp, Cp into Vp, C1 plus C2 into Vp. Now it is Vp is common. Vp get cancelled here. Vp get cancelled. What happens? Cp is equal to C1 plus C2. Now equation number 5. It is the expression for equivalent capacitance of parallel combination of 2 capacitors. If the more than 3 capacitors, at that time Cp is equal to C1 plus C2 plus C3 and so on up to Cm. Like this. This is for more than 2 capacitors up to n number of capacitors. This is about series combination and parallel combination of the capacitors. And one more point to remember here. Here asking the examination for series combination for 3 marks. Asking the examination for parallel combination, this is also for 3 marks. You obtain the expression for this one. ವಿಡಿಯೋ ಕ್ಲಿಪ್ ಮಾಡಲಿಕ್ಕೆ ಟೈಮ್ ಭಾಳ ಕಡಿಮೆ ಇರುತ್ತೆ ನಮಗೆ, ಅದಕ್ಕೆ ಅದನ್ನು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಅದನ್ನು ಮಿನಿಮೈಸ್ ಮಾಡಿ ನಿಮಗೆ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ವಿಡಿಯೋ ಕ್ಲಿಪ್ನಲ್ಲಿ ಕೊಟ್ಟಿರುತ್ತೆ. ನೀವೇನು ಮಾಡಬೇಕು ಸ್ಟೂಡೆಂಟ್ಸು, ಆ ವಿಡಿಯೋ ಕ್ಲಿಪ್ಪನ್ನು ಪದೇ ಪದೇ ನೋಡಿ. ಅದು ಒಂದು ಅಡ್ವಾಂಟೇಜ್ ನಿಮಗೆ, ಯಾಕಂದರೆ ಎನಿ ಟೈಮ್ ನಿಮಗೇನು ಸಿಗ್ತದೆ, ವಿಡಿಯೋ ಕ್ಲಿಪ್ ಸಿಗುತ್ತೆ ನೋಡಲಿಕ್ಕೆ. ಪದೇ ಪದೇ ನೋಡಿ, ನೋಟ್ಸ್ ನೋಡಿ, ಅದು ಅರ್ಥ ಮಾಡಿಕೊಂಡು ನಾನು ಶನಿವಾರದಿಂದ ಅರ್ಲಿ ಮಾರ್ನಿಂಗ್ ನಿಮಗೆ ಒಂದು ಮಾರ್ಕಿಂದು 2 ಮಾರ್ಕಿಂದು 1, ಆಮೇಲೆ 3 ಮಾರ್ಕಿಂದು 1, 5 ಮಾರ್ಕಿಂದು 1, ಬಟ್ 5 ಕ್ವಶನ್ ಕೊಡ್ತೇನೆ ನಾನು ಅರ್ಲಿ ಮಾರ್ನಿಂಗು. ಈವ್ನಿಂಗ್ ಅಂದ ತಕ್ಷಣ ಅದನ್ನು ಬರೆದುಬಿಟ್ಟು ನಮಗೆ ಸೆಂಡ್ ಮಾಡಿ. ಆಮೇಲೆ ನೈಟ್ ನಾನು 9:30 ಮೇಲೆ ಎಷ್ಟು ಸ್ಟೂಡೆಂಟ್ಸ್ ನೀವು ಬರೆದಿದ್ದೀರಿ, ನಿಮ್ಮ ಫೀಡ್ಬ್ಯಾಕ್ ಇಮಿಡಿಯೇಟ್ ನಾನು ಪೇಪರ್ನೇ ಬರೆದು ನಿಮ್ಗೆ ರಿಟರ್ನ್ ಮಾಡಿಬಿಡ್ತೀನಿ ನಾನು. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. My dear students, in this video clip I am going to explain that is the energy stored in capacitor. Energy stored in capacitor. Now what type of energy is stored in capacitor? Here the electric potential energy is stored in the capacitor. Now what is the use of capacitor? It is used to store the electric charge. It is used to store the electric potential energy. Once you store the electric charge in the capacitor, definitely it will store the electric potential energy. Now, a battery of capacitance C is connected across the capacitance C is connected across the battery BA. A capacitor of capacitance C is connected across the battery. Then what happens? Now electrons are removed here. Electrons are removed and electrons are collected here. Now suppose this is a plate X, this is plate Y. X is gone charged with positively charged. X ಏನು ಮಾಡುತ್ತಾ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ Y ಏನು ಮಾಡುತ್ತಾ ಎಲೆಕ್ಟ್ರಾನ್ ಕಲೆಕ್ಟ್ ಮಾಡುತ್ತಾ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಪೊಟೆನ್ಶಿಯಲ್ ಅಕ್ರಾಸ್ ದ ಕೆಪಾಸಿಟರ್ ಏನಾಗುತ್ತಾ ಡೆವಲಪ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಯು ಸೆಟ್ ಟು ಬಿ ವಿ ಆರ್ ಯು ಸೆಟ್ ಟು ಬಿ ವಿ ಡ್ಯಾಶ್. Potential difference across the capacitor is developed. Now that is said to be V dash. ಆಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ ಕಲೆಕ್ಟ್ ಆಗ್ತಾ ಹೋಗ್ತಾ ಆಫ್ಟರ್ ಸರ್ಟನ್ ಟೈಮ್ ಸ್ಟಾಪ್. ದಟ್ ಈಸ್ ದ ರಿಮೂವಲ್ ಆರ್ ಫ್ಲೋ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಟ್ ಮೀನ್ಸ್ ದ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜ್. ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಕೆಪಾಸಿಟರ್ ಈಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫುಲ್ಲಿ ಯು ಸೆಟ್ ಟು ಬಿ ಚಾರ್ಜ್. ಅವಾಗ ಅದು ಚಾರ್ಜ್ ಆಗಿದೆ ಅಂತ ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಲ್ಲ, ಸ್ಟಾಪ್ ಆಗ್ಬಿಡುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗೋದು. ಅಂದ್ರೆ ಚಾರ್ಜ್ ಹೋಗೋದು ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಫುಲ್ ಇದು ಚಾರ್ಜ್ ಆಗಿದೆ. ಚಾರ್ಜ್ ಆದಾಗ ಏನಾಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ನಾವು ಕ್ಯೂ ಅನ್ನ ಇನಿಷಿಯಲ್ ಚಾರ್ಜ್ ತಗೊಂಡಿನಿ. ಇ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್, ಬಿ ಅಂದ್ರೆ ಬ್ಯಾಟ್ರಿ, ಸಿ ಅಂದ್ರೆ ಕೆಪಾಸಿಟನ್ಸ್ ಆಫ್ ಕೆಪಾಸಿಟರ್, ಪಿ ಅಂದ್ರೆ ವಿ ಆರ್ ಯು ಸೆಟ್ ಟು ಬಿ ವಿ ಡ್ಯಾಶ್ ಇಸ್ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಕ್ರಾಸ್ ದಿ ಕೆಪಾಸಿಟರ್. ಇವಾಗ ಏನಾಗುತ್ತಾ ಚಾರ್ಜ್ ಹೆಂಗ್ ಮಾಡ್ತೇವೆ ನಾವು? ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ರಿಮೂವ್ಡ್ ಇಂಟು ದಟ್ ಇಸ್ ದ ಈ ಚಾರ್ಜ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. ಅಂದ್ರೆ ಟೋಟಲ್ ಚಾರ್ಜ್. ನಾವು ಚಾರ್ಜ್ ಅನ್ನ ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಳ್ತವಲ್ಲ ಅದನ್ನ ಒಟ್ಟಾರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಆಗಿರ್ತದ ಅಥವಾ ಗೇನ್ ಮಾಡಿರ್ತದ ಅದ್ರ ಮೇಲೆ ನಾವು ಟೋಟಲ್ ಚಾರ್ಜ್ ತಗೊಳ್ತೇವೆ. ಇವಾಗ ಚಾರ್ಜ್ ಮೂವ್ ಆಗುತ್ತಲ್ಲ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ ಆ ರಿಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ ಒಟ್ಟಾರೆ ಚಾರ್ಜ್ ಆಗೋವರೆಗೂ ಅವಾಗ ಅಷ್ಟದು ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಯು ಟೇಕ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ. It is very important. During charging the capacitor, whatever the total amount of work done, that work done is in the form of energy, electric potential energy. It is stored in the capacitor. Now, that electric potential at any time, when it is charged with the charge Q, V dash is equal to Q by C. According to the definition of C is equal to what? Q by V. Therefore, what you say? P is equal to V is equal to what you have to take here? Q by C. Instead of V, you take here V dash. Fine. During charging the capacitor, to drive the charge is said to be dq. To drive the charge dq. At that time, small amount of work done for transferred the small charge dq. dw is equal to V dash into dq. Why? Because electric potential now dq is the small amount of charges drive or transferred. dw is the small amount of work done. According to definition of the potential, what you say? Work done divided by charge. Small work done divided by small charge. Now dw is equal to v dash into dq. Now dw is equal to v dash is q by c into dq. Total work done for charging the capacitor from 0 to q. How to take here? That W is equal to integration over 0 to Q into what you say integration over 0 to Q dW. It is the total amount of work during the charging the capacitor from 0 to Q. Now this is the 0 to Q. What is dW? Q by C into what you say dQ. Then W is equal to, what is it? No, this integration is applied only for variable. Variable is charge 0 to Q into dq. Yes, integration over x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 is the integral formula. If you apply the limit, this is said to be definite integral. Now upper limit b, lower limit a. Now see, this is 1 by c. Now integration over this one is q raised to 1 plus 1 divided by 1 plus 1, upper limit q, lower limit c. Now w is equal to, yes, 1 by c, q raised to 2 divided by 2, upper limit q, lower limit 0. Now you put the first upper limit 1 by c, that is q square divided by 2, and then lower limit, it becomes 0. What you got here? Q square upon 2c. This is, you say, work done. You say equation number 3. Here W is equal to potential energy. Therefore, this electric potential energy U is equal to 1 by 2 Q square by C. You say equation number 4. You know that Q is equal to CV. Q is equal to CV. Q is equal to CV. Then substitute here. Now Q by C is equal to V. Rearrange this equation. Therefore, U is equal to 1 by 2 CV, C square V square divided by P. U is equal to 1 by 2 CV. Now this one, Q is equal to C square V square. V get cancels. Yes, CV square. C is divided by C. C get cancels. CV square you got. This is another expression. Expression number 3. This is one expression. This is another expression. And one more expression you got here. U is equal to 1 by 2 Q by C into Q you got. Now Q by C is V. Therefore U is equal to 1 by 2 V into Q. This is the one more expression. This is equation number, this is 5. This is, you take here 6 here. Now see here, the equation number 4, equation number 5, equation number 6, they are the expression for energy stored in the capacitor during charging the capacitor. When you charge the capacitor, at that time energy stored is 1 by 2 Q square by C, or 1 by 2 CV square, or 1 by 2 Q into V, or is said to be V into Q. Then, now energy stored in the capacitor, it depends upon what are the factor, charge in the capacitor, potential difference across the capacitor, it depending upon one more, capacitance of the capacitor. Energy stored in the capacitor is in the form of electric potential energy. Thank you. My dear students, now already you know the different types of capacitors. But already you obtained the expression for the capacitance of the one type of capacitor, that is said to be a parallel plate capacitor. Here other types of capacitors. Now what is the capacitance of that capacitors? Now see here, in the case of parallel plate capacitor, that is capacitance C is equal to epsilon naught A divided by D. A is the area of each plate, D is the distance between the two plates. This is for air medium. Other than air medium, epsilon naught into epsilon R into A divided by D. You got the expression for the parallel plate capacitor. And another two types of capacitors, one is spherical capacitor and another one is cylindrical capacitor. Now this is a spherical capacitor. There are two spherical cells. This is the A, this is the B. Hollow spherical cells, spherical conductors. They are concentric spherical conductors. Center is common for both. Now outer cell is connected to the earth. Now A is outer radius of the inner spherical shell. B is inner radius of the outer spherical conductor. Once again I repeat, A is outer radius of inner spherical conductor, hollow spherical conductor. B is inner radius of outer spherical conductor. Then suppose it is filled with a dielectric epsilon naught, dielectric constant epsilon naught. Now see, then capacitance C is equal to 4 pi epsilon naught AB upon B minus A. This is the expression for the capacitance of spherical capacitor. When the air is used between the two spherical conductor, it is a radial space. You say radial space. If the in radial space is filled with other than air medium, at that time C is equal to 4 pi epsilon naught into epsilon naught AB by B minus A. This is the for spherical capacitor. In syllabus nalli ಅಲ್ಲಿ ಥಿಯರಿ ಒಳಗೆ ಎಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ, ಎಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಇಲ್ಲ, ಇಕ್ವೇಶನ್ ಇಲ್ಲ, ಬಟ್ ಎಕ್ಸರ್ಸೈಸ್ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಇದಾವೆ. ಅದಕ್ಕೆ ನಾನು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಹೇಳಿದ್ದೇನೆ. ಎಸ್, cylindrical capacitor. In a cylindrical capacitor, there are two cylindrical conductors. Now these are what you say, axis is common for both the cylindrical conductors, coaxial said to be. Now A is outer radius of inner cylindrical conductor, B is inner radius of outer cylindrical conductor. A is outer radius of inner cylindrical conductor, B is inner radius of outer cylindrical conductor. Each of length is L. L is the length, and the outer cylindrical conductor is connected to the earth. Suppose it is filled with the radial space is filled with the dielectric constant epsilon r. Okay. Suppose here it is only there is a epsilon naught. If other than here epsilon naught into epsilon r you have to take. Now the capacitance of the cylindrical capacitor 2 pi epsilon naught L divided by 2.303 log of B by A to the base 10, or C is equal to 2 pi epsilon naught L log to the base E B by A to the base 10 ಇದ್ರೆ ಇದು ಇರುತ್ತೆ 2.303, to the base E ಇದ್ರೆ 2.303 ಇರಲ್ಲ. ಆಮೇಲೆ ಲಾಗ್ ಆಫ್ ಟು ದ ಬೇಸ್ ಈಗ ನಾವೇನಂತ ಬರೆಯೋದು, ಲ್ಯಾನ್ ಅಂತ ಬರೆಯೋದು. ಕೆಲವೊಂದು ಬುಕ್ ನೊಳಗೆ ಲ್ಯಾನ್ ಅಂತ ಬರೆದಿರ್ತಾರೆ. ಎಸ್, ಫೈನ್, ಓಕೆ. ನೋ ಇಟ್ ಇಸ್ ಫಾರ್ ಏರ್ ಮೀಡಿಯಂ. If other than air medium, instead of epsilon naught, at that time you take epsilon naught into epsilon r. ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು, epsilon naught ಇರುವಲ್ಲೇ ಏನು ಮಾಡಬೇಕು, epsilon naught into epsilon r ತಗೊಳ್ಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಕೆಪಾಸಿಟರ್ಸ್ ಆಫ್ ದಿ ಕೆಪಾಸಿಟರ್ ಸಿಗುತ್ತೆ ಅದರ್ ದೆನ್ ಏರ್ ಮೀಡಿಯಂ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಲಾಸ್ಟ್ ಪಾಯಿಂಟ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಆಲ್ಮೋಸ್ಟ್ ಈ ಚಾಪ್ಟರ್ನಲ್ಲಿ ನಾವೆಲ್ಲ ಡೆರಿವೇಶನ್ಸ್ ನೋಡ್ದಂಗಾಯ್ತು. ಪದೇ ಪದೇ ವಿಡಿಯೋ ಕ್ಲಿಪ್ಸ್ ನೋಡ್ರಿ, ಕ್ವಶನ್ಸ್ ನೋಡ್ರಿ. ಯಾವ ಕ್ವಶನ್ ಬರೋದಿಲ್ಲ ನನಗೆ ರಿಪ್ಲೈ ಮಾಡಿರಿ, ನಾನು ಆನ್ಸರ್ ಮಾಡಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.